think 2014 when we were starting to do TensorFlow, pre-transformer days. So this guy put a small camera, put a couple of conveyor belts or whatever, and used TensorFlow to running there to recognize different cucumbers and subtypes. It's amazing what people are doing. I learned a lot. In the end, that didn't quite pan out how I wanted, but I learned a lot. It's always, the learning in startups is crammed in a very short time.
What would you say, looking back, why it turned out the way it turned out? All right, so this is our episode 8, and in the history of Effortless Podcast, you're the very first guest, so very warm welcome, Rajat.
Thank you, Amit. Great to be here.
So I guess Rajat and I have known each other for more than a decade. I think I met you first at Google at the very beginning of Google Brain project, where I was leading a machine learning team in ads. And you were getting the Google Brain project off the ground, and we started talking in that context.
Yep, it's been a long time, and we've stayed in touch ever since, sometimes more and other times less, but yeah, it's been great.
And for those who don't know Rajat, I think Rajat is very well known for being the creator of TensorFlow, and he also founded Inference, and right now you're a corporate vice president of engineering at Microsoft.
That's right.
And if I understand correctly, you're leading the team that's building the next generation inferencing infrastructure.
So yeah, my team is responsible for the AI software, the stack for both cloud and the edge. So all the way from the largest models that we run, including like GPT-4o, etc., that you use, to tiny models or not so tiny SLMs that run on the edge, on Windows devices as well as mobile phones, etc.
So you've done the whole gamut from like Google in its heyday to founding a company and then going to Microsoft. Maybe let's start there. How has it been, these 3 different experiences, and how do you contrast them?
Yeah, each has been an amazing experience and a journey. They all have interesting differences. So I joined Google back in 2009 and started in ads as well. In fact, this is before we met. But I spent a couple of years there and ended up meeting Andrew Ng and Jeff Dean just as they were starting out what became Google Brain. And this was an exciting area that I'd heard about before. I'd read a little bit about neural nets, but it felt like just the right thing to do. I mean, looking back, of course, it was amazing. Back then, it was still a research project or an idea that we'll see where it goes. So from then on, the journey, like ads was somewhat more standard, a larger company, still a great place. I enjoyed it. This was more like a startup within Google in some ways. Early days, a bit of research, not just a pure startup where you're trying to build things. But we started getting results very early on, and so had the opportunity to partner with tons of teams and grow, etc. And we saw amazing growth during the next 7-8 years that I was there, building our initial systems and then V2 of those systems as TensorFlow, and continuing to grow both inside and externally. So that was lots of fun. It was, looking back, it was one of the most amazing experiences I've had. But as I think about just whether it's Google or any other company, etc., some of those experiences are point in time, very specific place, people, all of the right things happening at the right place. And it's hard to compare that in that sense with every other experience, right? If I then, after that, I decided to do a startup, kicked off Inference, which was its own journey, started just before COVID, went through that, the COVID process, but also the startup, right? Just I had been at startups before as an engineer, but that's very different from getting a startup off the ground. You've done this before, so you've seen that before as well. It was hard in lots of ways, stretched my learnings in so many different ways, way more than I thought it would. It was an interesting, journey with lots and lots of ups and downs. I learned a lot. In the end, that didn't quite pan out how I wanted, but I learned a lot. It's always, the learning in startups is crammed in a very short time. And
Yeah.
learning all kinds of different things. There were the things that I knew well of. Okay, I know how to build products, etc. Then there's, okay, how do you take that product and make that work for somebody where they're willing to pay you money for that? And that's a whole new way of thinking that you need to go through. And now coming back to a larger company, Microsoft. In some ways, it's very much like Google in that it's also a large company, which comes with its pros and cons, right? There's already a huge market that we can go after. There's a huge user base, set of customers. But every company has its own culture and DNA in some sense. Whereas Google really got the consumer side. Google was very much started as a search company, so always next directly to users. Microsoft's very much an enterprise company. And some of their DNA shows where Google, I would always hear that people are, oh, Google doesn't hear what we say, etc. And it's hard when you're talking about billions of people. You can't really look at individuals. Most of the things you're learning are from stats and just the numbers, and that's what you start doing. Whereas here at Microsoft, it's all about the customer. And so we're going from the customer is important. It's all about how can we help customers solve real problems? How do we service them? That's something I'm learning a lot more, how well you can do that. That's been a great experience.
Very cool. So there's so much to dig in here. I'm split between whether I start with TensorFlow or your Inference experience or Microsoft. I guess let's go chronological. So TensorFlow. I feel like it was one of those big inflections in the field of machine learning. Just like without AlexNet, today's machine learning wouldn't have been possible or would have a very different path. I feel like if you guys hadn't built TensorFlow, we wouldn't have TensorFlow, we wouldn't have PyTorch, we wouldn't have the tools that the research community needed to get to where they needed to. So I think without TensorFlow, we would probably be looking at a very different scene of AI today. Would you say that's fair?
I think so. I think the timelines would definitely have shifted. I feel like a number of things accelerated because of that. One, we were able to scale things a lot more. Everything before that, like outside of Google, and the reason Google started TensorFlow, we had this software called Disbelief, which we were able to scale things from one machine or two to thousands of machines. Although we started on CPUs, so it's still very different. But by the time we went through that 2-3 years, we knew that there's a lot of value we want to deploy in terms of products. And so we wanted to scale this up. We wanted to be more flexible, so that was one thing that TensorFlow got in learnings. The other was we still want to scale up, but with accelerators. So by this time we had GPUs in the fleet, which we had patched into our last thing. We had TPUs coming up, and we wanted to do all kinds of new kind of models. Sequence models were just starting out at that time. I think 2014 when we were starting to do TensorFlow, we had, again, patched in RNNs and LSTMs. It was pre-transformer days, so just patched them in and figured out how to make it work, but it was super hard. And state of the art outside of Google was Theano, which was some similar ideas. Obviously, we borrowed some ideas from there, I would say, but still a very much a research project built with like 2 or 3 engineers over time, or research students really just adding patching on things. Or Torch, which is the Lua based Torch, which there were maybe 2 labs in the world that wanted to use. It was good, but very limiting in terms of what people wanted to do with it. So I think what it changed was, one, a bit of scale and flexibility that people didn't have before that, and 2, I would say, outside the research community also people started to take notice. That was the first time I would say I saw, students are starting to get into ML more and more, right? We heard of over the next year, once we launched TensorFlow, we heard of so many different projects that just students or people were building and solving problems. One that I still remember that we talked about then was this guy who was an engineer, embedded systems or whatever. His parents had a farm back in, I believe, Japan, if I remember right. Old parents, they have this farm making cucumbers and they had to sort stuff. So this guy put a small camera put a couple of conveyor belts or whatever and used TensorFlow to running there to recognize different cucumbers and salt depths. It's amazing what people are doing.
Yeah.
But that was exciting.
So the contribution of TensorFlow was mostly scaling things, or was it like a easier interface for programming neural nets, or both?
I would say both. I would almost say three sides, right? There's the scaling part, which is valuable in one direction, the flexibility at that time for researchers, because they could try out new ideas. They could essentially put any math in there, get the gradients automatically. They don't have to always write them, right? That does make a difference. And the third one was more on the applied side, where now engineers or product folks could start using ML. And so they had enough usability, ease of use that they could try that, right? Which is not possible before.
And in some ways, CUDA is a layer below TensorFlow, right?
That's correct. CUDA is much slower, tied to GPUs, but NVIDIA GPUs basically, right? NVIDIA opened that up. That CUDA was interesting in that it allowed AlexNet kind of things to come up. The reason that network worked well was Alex Krzyzewski, this is named after. He was working with Jeff Hinton and Ilya, and they came up with this model that could go beyond one GPU. They optimized it, and Alex was super good at writing CUDA kernels, so he could optimize it enough to train on the ImageNet data set fairly efficiently. The trick with a lot of ML is you don't get everything right on the first try. You have to assume that. And so the only way to make progress, and this is true for science in general, is to be able to do a lot of experiments.
Yeah.
And the faster the experiments go, the better you are.
Yeah.
Right? The person who can do the experiments fastest usually wins in the long term, because that's way better than anything else. That, by the way, is something I feel like is true for startups as well.
Yeah.
The startups that can iterate the fastest, they don't have to be right the first time.
Yeah.
It's not about thinking for a long time and coming up with an idea. It's often about being able to iterate rapidly. Right? And I don't know if you have thoughts on that. You've done ML and startups as well. What's your experience been in some of this?
Yeah, no, I think the thing that I took from 5 years of working at Google was really, in order to do anything substantial, you need to get a few things right. A, you need a way to test your hypothesis very quickly. B, you need to have a really good measurement system that can measure really small differences, because most ideas don't produce gigantic gains. But if you can tell signal from noise, even from the 0.1% gain, then you can stack a lot of them and over time get a lot of gains. And C, you need a team of creative engineers who are given the freedom to experiment a lot and who move fast. And if you put these three things together, you can make amazing progress. My team was responsible for 10 billion top line revenue, and we were tasked to improve it algorithmically by a couple of % every quarter. And over a long time, when you add them up, they don't add linearly.
Yeah, of course.
But even then, the amount of top line revenue that we could bring as a small team of 10, 15 people was just mind blowing at the time. And same thing for startups. I think your initial ideas are always quite bad. And it takes a lot of doing and experimenting and working with users to eventually figure out what actually works.
Actually, on that, I wonder, and this is my startup experience as well, but I always wondered, you've done this more. So you talked about being able to measure those like really tiny 0.1% or whatever, right?
Yeah.
At the scale of Google, and particularly in the consumer side, etc., because you have tons and tons of data, each day you're getting more billions of queries. Possible to do that. Right? I mean, forget easy, it's possible. How do you do that with an enterprise startup, right? Where you have a small number of customers, if you maybe have a handful of design partners when you're starting out, right? So what worked for you then?
I think over there, it's the anecdotal evidence. Sometimes when you have a ton of data, or like when you're serving a lot of customers, pretty much the only way you can have something meaningful is stats driven. You and I were talking about that, right? But actually, when you're working with one design partner or 5 design partners, that's a beautiful part of exploration where what you're seeing is a lot more human, and you're seeing somebody's eyes light up. You're seeing somebody's reaction to your product. You can see the session that they've gone through. And if they love your product, there's an unmistakable sort of reaction that you capture. And sure, there's a danger that it may be like N of 1 and it doesn't generalize, but you can test for that very quickly and you can find patterns. So it's a lot less data driven, it's a lot more intuition driven, but that testing is still super important.
Yeah, but by the way, the N of 1 that you said, it's always saying, I've heard more so than done, honestly, even with my thing, but having one person or one customer who loves your product is way valuable than 3 who just like it or are okay with it. And so that's a great thing.
No, I think when we started demoing ThoughtSpot to potential customers and customers, the very first design partner said our jaws are on the floor.
That's awesome.
It has taken us a long time to figure out distribution, and we had to change the form factor as the world moved from more on-prem to cloud and things like that. But that kernel of innovation that we had has always resonated really well with customers.
Yeah, that's awesome. Yeah. That's a great one to have, right? And that talks about the success that you've had as ThoughtSpot as well, right? Speaks to that well.
So coming back to TensorFlow, I've always been curious what caused. So when I talk to most of my ML friends, it seems like over time TensorFlow has lost a little bit of shine and PyTorch became the darling. How were you seeing it, and what happened that made it possible?
Yeah, here's the thing, right? You learn from the products that come before you and your experiences. So when we created TensorFlow, there were a few design choices we made. And there are a number of reasons why we made those. I can walk through a few of those. So and we learned from our experiences just running deep learning at scale across Google. And from our prior platform, Disbelief, from a few things that were there at that time, libraries like Theano and Chainer, etc., which most people starting today probably haven't heard of at all. Some of those, one choice specifically that we made, where we wanted to make sure TensorFlow worked really well, not just for research, but also for deploying models that we built. And that led us down a choice of having a graph that is created before we run it. So for programmers, they think about the compiled languages and the interpreted languages. This was more like a compiled thing, right? We were first writing the thing and then compiling. You essentially, in this case, create the graph and then you run it, right? Execute.
So that way, execution on that graph is a lot more efficient.
Exactly, right? And so that was one design choice we made, which I think in hindsight still continues to, for deployment perspective, that's still a much better way of doing it. But on the other hand, over time, it did, if you compare it to a purely interpreted language, it does make it slightly harder trying out new things, or every step is slightly slower. It takes a little bit longer. And that's where PyTorch focused on. The ideas came from Torch. And in fact, Chainer was another Python package which had the same idea. So this had been there a long time ago. And this was it wasn't a random choice. We actually talked about it, but decided against it. And PyTorch chose to go just that interpreted way, partly because the folks who were doing that, Amit and Jan, in fact, I talked to him a few times, and Jan was always like, okay, you know what, nobody's going to use graphs. I'm never going to do that. He was involved in the Torch piece, and he was always using that, right? He does want that. In fact, he didn't even like Python, but that's a different story. He wasn't excited about PyTorch, but Amit continued anyway.
Yeah.
But from a pure research perspective, if all you care about is research, then that's a fine thing to do, right? Let's just optimize for my initial thing. And somebody else will figure out deployment. And when Summit started this in the research group, he didn't care about deployment, or Facebook at that time was using Cafe to, in fact, they still continue to do a little bit of that, I believe, for deployments, because that did that part well, not the other side, right? And over time, as things progressed, particularly with NVIDIA GPUs pushing in, and you could almost say NVIDIA optimized PyTorch heavily for their hardware. Great for them. Helped cement, in some sense, their leadership, right? They were ahead in many ways, but this definitely helped. and optimized away the overheads, because what the Python piece meant that even for anything large scale, it wasn't as fast. But some of that helped get those things together. On the other hand, on the TensorFlow side, we realized that yes, we want more of that flexibility. Ideally, we wanted to do it without giving up most of the graphs, etc., because there's a whole ecosystem we'd built around deployment, etc. And that's when we decided to do TensorFlow 2.0 with still that eager mode, but with making it very easy to get the graphs, etc. And PyTorch on the other side was trying to do that as well, to get the graphs somehow for deployment. Right? Fast forward a few years on the core tech piece itself, that those directions have been fine. PyTorch still has issues from a deployment perspective. For some things it doesn't matter because the time it takes on the GPU, and again that's an area that NVIDIA has done a great job of. You essentially offload everything to the GPU after the first run, so people don't care, which the same thing would work here as well. But I feel, and this is partly the large company thing and the change of guard thing, I left Google shortly after TensorFlow 2.0 launched, and in some ways, look, any new system, new version, the launch is not the end, it's the beginning. Right?
Yeah.
You have to, it takes a lot of effort because there was you're going from a system that's not fully backwards compatible. We built a bunch of tooling, etc. to do that, but there's still a lot of work to do to really get people over and make that experience amazing. I think with a lot of organizational changes, that whole direction got lost, and it needs, for something like this to work well, you need a lot of things to come together. Like internally at Google, people started using JAX. That came up for a research perspective. Again, more focused on research, didn't care about production. In the long term, it feels, for example, and that's because Google doesn't care as much about it. It's hard for the rest of the world to care. So you've seen a little bit of shift. That said, people still deploy a lot of things with TensorFlow, even at Google, but I still know a lot of companies that are doing that, and there's value to doing that. People still have issues with deploying PyTorch. Like at Microsoft, we use Onyx Runtime, which is also open and very much focused on the deployment side of things. So it's not like we are in the best place possible. It's, in ML parlance, we are in this local minimum that we've hit because of the path we took, and we just happened to be here, right?
Is this a classic case of innovator's dilemma? That you built TensorFlow with a particular use case, particular customer in mind, and PyTorch came and acquired a different customer that initially didn't care about, which is the research community. And then that kind of took a life of its own and eventually took over sort of production use cases as well.
There's definitely a flavor of that, right? I would say in some ways with TensorFlow, at some point it became so big that we are targeting too many different personas, and it's hard to be the best at every persona. That's a classic thing, right? And you pick, there's one niche that is the worst for you, and when somebody comes in and does better, they'll address that. Right?
Yeah.
It's not an easy one to crack. I think when I was there at TensorFlow, I'm sure there were things that we could have done better. Yeah. But there's also, it takes a lot of effort to get that right.
But is that something as an organization Google even cares about? Like, why would Google care whether the rest of the world uses PyTorch or TensorFlow?
So I can give you one very simple example, right? Google cares about TPUs and Google Cloud. I think if TensorFlow was still the number one thing, TPUs would be doing a lot better from the outside as well. Google still, if you look at any accelerator other than GPUs is by far clearly the number two, and even be better than GPUs in some places, not generally, it's not as general, but the programmability is still a hard one. And while Google's tried to address it by supporting it with PyTorch, etc., and JAX, there are not that many folks outside of Google that use it. And most of the bigger groups that use it are ex-Googlers.
Yeah. Very interesting. And do you think for either training or for inferencing, TPU is a better piece of hardware than NVIDIA? Or you think they're like better at some things, worse at some things? And is it just that the social acceptance or popularity of the software frameworks that's driving the world more towards NVIDIA chips than TPUs?
So NVIDIA chips are, they're GPUs, right? As they call it, general purpose GPUs or whatever, they're definitely more flexible and they are more programmable at the lowest level with CUDA. Google has, with TPUs, you have XLA that you can use to program them in some sense, and the higher level it's either TensorFlow or JAX, and now PyTorch as well that targets it. But that's still a much higher level. Over time, Google's built like more things like Pelas, which is like the layer below which you can write your own kernels, etc. But that's still more limited. So that limits the flexibility a little bit. I think where TPUs, I would say, shine are not just a single chip. They might be, say, slightly more power efficient than a GPU for certain kinds of things. I don't know where they are. I haven't looked at the numbers more recently. But as you look at larger systems, if you're trying to run, and a lot of the large models today don't fit on a single chip. They run on multiple chips. Within a single node, you're still okay with NVIDIA. They've optimized the within the node fairly well. As you start to go multi-node, especially on the training side, that's almost always needed. That's where the entire system that the TPUs provide with a lot of custom interconnects, etc., that's really designed for this and does a lot better job than some of the others. Now, where you'll see most of these differences are at much more large scale things where you're training large models, training across lots of really large groups for a while. So not everybody cares about that as much today. If they were as programmable as NVIDIA GPUs and Google Cloud was as good as everybody else, etc., then it would be a real competitor.
Very interesting.
On the other hand, in this case, just to give a third entry, AMD, at Microsoft we use AMD GPUs as well, and we've been building our own custom accelerators too. And AMD has done a great job again on the GPU front. We've deployed them at scale now. But it's still, building the systems takes a while, and so over time we'll see a lot more.
So you think AMD has a real shot at giving NVIDIA a run for its money?
I think so. On Microsoft side, we're definitely betting on it. We are deploying them in large numbers. We're using them, very recently we deployed GPT-4o on AMD things, and it's pretty competitive. The hardware is really good. The software's come a long way. That stack, there's still work to do, but it's definitely something that it's doing well.
And like competition is good for everyone, right?
Exactly.
So they'll push the prices down. Yeah. So right now, would you say that inference is cheaper on AMD than NVIDIA?
Perhaps, yeah. They're definitely in the ballpark. I would say it might even be cheaper on AMD. Yes.
Very interesting. Okay, let's get to the second arc of your career. What got you excited about starting Inference, and how did that happen? The origin story or so of Inference.
Yeah, it's definitely. Those were times then I talked to you a lot as well, I remember. And around 2019 and talking about as I decided to step away from TensorFlow, we were ready to launch TensorFlow 2.0. Things were in line. And it just felt okay. I'd been thinking about doing a startup for a long time. Before Google, I'd done, I'd been at a startup very early, like the first person building the engine and the product piece. And I've always liked building things. In some ways, that's the reason I joined Brain, when we did, and just building things from scratch. That's something that I've always enjoyed. And so that was always an idea that, yes, at some point I want to go back and do something. That just 2019, it felt like the right time. Okay, now TensorFlow is in a reasonable place. Obviously, who knows the future, but let's go and think about something. So when I left Google end of 2019, I still didn't quite know what I'm going to do. I knew I'm going to explore and figure out. There were 2-3 areas that I explored. The first one was, and the reason I thought, which I believe in you now, but perhaps how we do that is going to be interesting, is that I felt like ML needs to going to be running more at the edge over time. And so how do we make that possible? If that's the case, how can we make that possible? In the end, I decided against it, partly because to run ML at the edge, you first need the core systems in place. And it felt like, yeah, they're there, but they're very fragmented. Unlike, say, the mobile phone market or even the laptop desktop market, where there are a couple of players which cover the majority of the things. In IoT, they're like every company has their own stack pretty much.
Yeah.
And there were
who are these companies? Give me a few examples.
So if you think about industrial, so Siemens or Bosch and everybody has their own stack pretty much, right? So if you want to run something, you have to work with every one of those players to do that, right? If you come slightly closer to the consumer side, things were starting to be interesting. Say you have a washing machine or something. Everything needs to be smart today, right? In some fashion, good or bad. Like my fridge right now tells me, "Oh, you have so and so things in the fridge." Half the time is right, and I don't care. I don't trust that. But everybody wants more of that in there. So how do you do that at the end of the day, right? Now, on the consumer side, there were a couple of companies that had started to provide the stack so they can just integrate that. And that was an interesting thing, but at least the ideas I had seemed like somebody was executing very well on that. The second was ML infrastructure, of course, having spent so long in there, and okay, should we just build a company around that? And that, there were times when I came close to, let's do that. That's the default thing, right? Okay, we're running TensorFlow here, let's build a company around selling TensorFlow or whatever things around that. Would be a bad idea. I felt like that had just because of how some of these spaces work, that had a limit to how big you could go with something like that. Right? And my thing was, you know what, you don't do a startup all the time. It's a tough one. You're not there to just make something that's interesting. By the way, coming off TensorFlow, which was with all the things lining up, was hugely successful. I was like, you know what, if we're doing this, let's go swing for the fences. It may not work, but let's at least try it.
Yeah, that's the whole point of doing startups.
That's the whole point of doing it. And so then the third one that I ended up more in was data analytics, something that obviously you've looked at a lot and learned from some of our conversations, talking to a lot of people. And the problem that stuck to me was, as I started talking to people, it connected with everything I'd been looking at, whether in ads or things where we build dashboards. That's basically what analytics has been about, right? You have these charts and figures that you look at. Okay, I want to make sense of my data. But mostly what business leaders are doing is they're just looking at their revenue graphs or whatever graphs and hoping that everything's okay. Right? And then ignoring. And then making their own decisions on where they want to go, etc.
Yeah.
And even day to day, if things change, say a consumer company e-commerce company, your revenue is down today. What do you do to figure out what's going on? Now, somebody is going to go run a whole bunch of queries to make guesses essentially, validate. Maybe it's last time it was a problem in Texas, let's go look at that, etc. That just felt like we can fix it, do better. So that got me excited, and that's what I ended up focusing on basically. So a long story, but a fun one, right? And I remember some of our conversations from those days about you. By that time, already spent a fair bit of time with ThoughtSpot and Effortless. That was definitely an inspiration in the direction that you guys had taken things. But I wanted to start with a different angle on how can we automate the smarts, right, rather than the standard bread and butter, right?
Yeah. So I remember there were a bunch of companies that kind of got started around the same time with the idea of outlier detection and finding anomalies. There was Outlier, there was Sisu, there was Inference, and somehow it turned out that there wasn't a big enough market for this. What would you say, looking back, why it turned out the way it turned out?
So I think it's a weird one, right? So is there a market for this? You could think of this as a requirement for, at the end of the day, if I step back again, there are a few different tasks that I want to do as I think about my data. And this area solves for a certain set of tasks. Not all of them, some of them. Now, is those set of tasks the most important ones for somebody that they're willing to pay you a lot of money for, essentially, right? Typically, that by itself is not going to help you build a big business. but can that get you in the door so over time you can expand to the rest of it?
Mm-hmm.
Turned out it was hard for a variety of reasons that I've gone through some of those before, but in general it's not easy to find that fit, right? People talk about product market fit.
Yeah.
Sometimes product market and sales fit, etc. as well. Product market fit, I would say it's a mix here where is there a need? Most people will say there's a need. And I would say from my perspective, if I'm back now that I'm a company, I want to use that product. So there's a need there. But for most companies, is that a big pain that they're willing to pay for? Just where companies are, sadly, that's not the first thing. Companies still continue to have simpler issues. And they still want their dashboards, or somebody wants that dashboard that they're still going to pay for. So if I think back to those days, most people still had a Looker or Tableau instance. For whatever reason, the mid-size Looker was very common. And they still wanted that. Now, are they willing to part with some percentage of that for a different tool or to even get started? And it's hard to convince folks of doing that, particularly if the market is not great. I mean, you have to, if you time things just right and maybe, but it's not obvious, but maybe. So you need to have a way to get in that door. The second piece there becomes like, who is it for? And the pain that shows up here is usually for the middle management, etc. Because the top management, even if it's hard, they'll get the answers. People will do whatever it takes to get them the answers. It's the middle management who will not get the answers because it's just too hard. Whatever. You don't deserve this kind of support.
We're not going to do a fire drill for you.
But they don't have the money, right? They're not going to write the check. The check is going to come from the CFO or the CDO or whatever. And so classic sales problems, right? If you think about startups. From a product perspective, I still think I would like to have that product where, not Microsoft, I look at some numbers and I'm like, okay, I wish I had that. But that there will be, now can an existing player build that idea? Perhaps. But I think some of that to do, you have to rethink it. But it's a hard one, so I don't know.
I'm just going to dig a little bit just for the benefit of people starting companies and going through that early process of idea validation. What were the signals you were getting when you were trying to validate that idea with customers? And is there some sort of a lesson there in terms of maybe do this but don't do that, or don't take this on face value, or some such thing?
Oh yeah, definitely. And I'm trying to remember a book that I read about this specific thing afterwards.
You're talking about the mom test, maybe?
Yes, that was an awesome one, right? Actually, it's very easy to get excited about your own idea, and you, for sure, want people who are as excited as you are, or in some ways that, are they willing to sign up as design partners and spend their extra time with you to do that? We got some of that. I guess that's still not enough. Just one example, but we had a few. In fact, we continue to get a few after as well. Two, I would say it's important to separate out and peel the onion of why would they want it? How would they want it, right? How would they pay for it? Keep going deeper on some of those questions. And even if people are saying and some of the folks that I talked to, they were like, okay, if you can do this, there's so much money we can pay. But when it comes down to it, there are still nuances, etc. that come in. How do you peel that onion? And again, I didn't do it successfully, so clearly I missed a number of those things. But the important thing to what you were saying, Amit, is not taking much of it at face value. And how can you separate out? In our case, I would say, going to the answer, there's always, is it a pain? Most people would say yes. Right? So that's great. Is it their biggest pain? Is it fourth on their list? Too bad. Even if it's number 2 on the list, you will have to do a lot of work. But if it's beyond the top 2 or 3, then good luck, right? You're gone. You want to be that number 1 pain, ideally. So how can you nail some of that? And you've gone through this. In fact, I remember you talking about solving some of this problem at ThoughtSpot as well. back then I thought that wasn't the key focus for you guys. It
Yeah.
was just a nice feature or whatever.
Yeah.
Maybe I should have listened to you more deeply. But what are your thoughts?
I have thought about this problem for hard and long. And I think it was in 2016 that I first started building anomaly detection in ThoughtSpot. It was basically sort of me going in a hole for 2-3 months before the first version of Spot IQ came out. And in the beginning, it looked very exciting because what we were doing was we already had a lot of statistics about how people drill down into data. And so I had that sort of distributional information in the context. And so like, we can just automate this and drill down in all possible directions on behalf of the user. And then the question is, which one of these drill downs are interesting from an anomaly perspective? And so we're just using simple anomaly in the beginning. And you press a button and magically a whole bunch of charts appear with anomalies, and that looked like magic. But over time, what I started realizing was that simple anomalies are usually well-known facts within the organization. For example, the fact that a retail company's sales spikes up around Thanksgiving and Christmas looks like an anomaly, but it's something that they'll say, tell me something I don't know. Or for example, at Google, I remember revenue will spike up at the end of the quarter because people had quarterly budgets and they were trying to exhaust them. So from the outside, it may look like an anomaly, but from the inside, you know that this is a repeated pattern. Or if I tell somebody that if I plot your revenue across states, California and New York are an anomaly, they're like, are you joking? Those are the most populous and richest states. Of course, it's going to be, or like for a US-based company that has a little bit of business outside US, looks like an anomaly. So these are the kinds of things that create a lot of noise in which the signal gets buried. And at least in my case, initially the problem I was seeing was that I needed, the tool needed to know what the user already knows and what's their built-in mental model of how this number is supposed to move. Because maybe the assumption that revenue should stay flat across states is flat out wrong. And maybe revenue per store is a number that's a little bit more stable, or maybe revenue per capita. And so you have to do a little bit of engineering to figure out what is that number that's supposed to stay stable. Over time, what I've learned is that the easiest anomalies to pick out and the one that people care the most about is time series. And in time series, as long as you are able to look at far enough history, you can find the reasons for expected spikes, periodic spikes of holidays and end of quarter and stuff like that. And once you take that out, then rest of the anomalies are truly interesting. There could be things like when Olympics happen, they don't happen on a regular schedule and you need to find a way to put that. But so that's where at ThoughtSpot we're focusing now, is mostly on time series based anomalies and nothing else. And that does add value. But yeah, I think in general, I guess the lesson I took from the 3 startups in our own effort was that it's more of a feature for a dashboarding and analytics tool than a product category in its own. At least that's what it seemed.
Yeah. I agree with some of that. The time series part, I agree. I think removing that noise, etc., is important. And I would say I over-indexed on that in that I think we built a product around leveraging some of those ideas, that similar things that you talk about in more. And I would say on the product side, I think we made good progress. But what was a bigger learning for me, that's still only one part of the puzzle. You need a lot more things for it to actually succeed. I attributed most of and I looked at Outlier and Sisu, and they both had some things going for them. Outlier built a reasonable sized business before they ended up shutting down. Sisu was mixed, but there's a lot of stuff that goes into to actually being able to build a business around something like that. And you're right. Is this a feature or a product? That's an interesting one, right? My perspective, at least at that time, and to some extent now as well, is yes, this by itself is not a product. Although there are some places where people are willing to pay for it, you do need to build something that goes beyond. Personally, like from a pure product perspective, I would almost say we need to get away from the idea of that everybody needs to build their dashboards. That's not the best way of doing things.
Yeah.
But how do we change that? Because it's a lot of it is user behavior, how people are just used to doing things. It's a lot harder than just building a nicer product or better in some way. You spend years building in all dimensions, but then you'll probably get it wrong because you need to iterate. So I don't have an answer on how you would get there. I do see there are better end states.
Let's talk about that. If you could wave a magic wand and change the way people work with data in enterprise, what would be that ideal end state?
In enterprise, one, I would say, actually have all the data available. So many times, that is not there. That's the step one, right? Second, to start with metrics. People do, but not quite. There are three ways that people are used to looking at data. Okay, I have, let's say, a revenue. I'm used to, obviously looking at revenue over time. But then maybe two ways you typically slice it by, like you said, maybe states, the top states or the top categories, right? And sometimes I look at it over time, sometimes I don't. Honestly, I might want to look at it over time always, but depends on my analyst team. Right? If they find it easy, if the tool makes it easy, maybe they'll look at. Even today, you go look at most tools, and I haven't used ThoughtSpot enough. I've looked at Tableau and look at more. If you want to, and honestly Microsoft as well. I'm using Microsoft as well. But there's like making a dashboard, like the dimensions, etc. should be, I always want to be able to slice and dice if I want to. The user should be able to do that. So that's like just from a usability and this, but that's still manual, right? Ideally, once I've told the metric or once I've shared the metric, here's the data, and maybe there are some nuances that, you want to ignore things with this value because that's not production data, as an example. There are always some nuances like that, right? That's the modeling aspect in some sense. That's where people can help them. Beyond that, it's all about presenting the data in the right form. Which again, there are only so many ways to chart things, so they should be trivial to do. Second, the anomalies part that we talked about, there are enough techniques now to solve that. That's a reasonably solved problem. I think our approach we took, we solved it in some way. I'm sure there are other ways as well, but we can make a lot of progress on that, right? The ML part and the way I thought about the anomaly part was really, one is just you're looking at either time series or dimensions, etc. But at the end of the day, to your point, there's an expected value for today and there's a real value. Is there a significant gap? That's what you want, right? And the better you can do than the expected value, that you remove the noise, essentially. If you solve that problem, if you can predict the value well, then the rest gets better. And we're getting a lot better on the prediction side now. Right? So some of those are solvable. So really starting from, from the analyst perspective, etc., I should be like, okay, I can get the data in the right place. I can define my key metrics in the model. And for most part, that should be it. Then the visualization, there are two forms, right? A lot of it is, okay, can I get whatever chart I want? That should be easy to say. And that's the kind of thing where now, in fact, conversational interfaces can help pretty easily, right? It's an easy thing to map. Or even asking a very specific query because it can drill down once you've set up the right data. Then the common, then now you're like different parts, right? There's a strategic part where you want to look at high level stuff. So that's solved here. There's the operational part where you want to identify the anomalies, which algorithms should solve. And then there's maybe some analysis that you want to do to connect with the strategy, where you're trying to think about the exact answers or things, okay, maybe your scenarios or things. And that's where we should have the tooling which helps you or people do look through and deep dive a little bit, etc. Right? So all of this it's possible to have tools that solve this problem and make it super easy. I think we have different tools that do each thing well. We don't have anything that connects them well. And because Tableau is 15-year-old tool now. And ThoughtSpot has been around more than 10 years now, 12 years. Right? And there are still people use Tableau. Tableau has not changed that much. They really changed the scene when they came in. It hasn't changed much. And it has its problems, but people are very reluctant to move them. So moving them is still going to be very hard, right? So how do you do that? But from an ideal place, people shouldn't be building things, right? A lot of that should be just done for them.
Hey, so you said something that kind of piqued my interest. You said that predicting time series has gotten much better. I've seen a few papers and few ideas, but I haven't really seen any sea change in how you predict a time series from, let's say, 5 or 10 years ago. Are there things in that domain?
Transformers.
So
that's an extreme case. Actually, honestly, one thing that we tried, in fact, somebody we were working with who tried that, was to take a foundation model, which is not even built to predict time. You could say it's built to predict sequences. And we tried it on a data set where we had a whole bunch of, interestingly, podcasts. And we were seeing, okay, here are the views for those podcasts over time, and can we predict the next few months? And even taking a foundation model and maybe it had some knowledge of these podcasts or whatever, but it could do a great job at doing those predictions. Now, this had been trained on a ton of other data, not just that data, which is fine. What some of that other pieces of data can give it is the standard seasonality. Things change during summer versus winter versus festivals, etc.
So you're taking like an LLM like GPT-4 and just feeding it a time series?
In this case, as long as you can give it enough examples and just creating a prompt with enough examples, it can do more predictions as well.
And you're saying that's better than whatever the standard Arima or stuff like that?
Yes.
Very interesting.
So that was pretty cool, actually. I agree.
I've seen a few papers that sort of build transformer just for time series forecasting.
That as well, right? I think, and with transformers, you do need enough data, which is why training from scratch can be harder. But if you have enough, then absolutely, I think that's definitely a good way to think about it.
Very interesting. Cool. All right, now let's talk about the modern AI. The LLMs and inferencing and transformers. So you're at the heart of it. You're building the next generation inference infrastructure. Where are you trying to get to and what's hard about it?
That's an interesting question. Look, a number of things keep changing. If you think about it, if you take a problem and let's say a super large model, I want to run it on TPU or in our case Maya, which is our internal hardware, and you say, okay, I'm going to run this here, and you had enough time. You can build a fairly optimized inference engine for that. The problem today gets harder in a few ways. One, the models keep changing. Every 3 months, 6 months, you have a new model, which is either bigger, different, you have multimodality, etc. that you need to think about. The data, the scenarios keep changing because the model's capabilities are changing. How people want to use that is changing. So that means, say, if we think of, say, a ChatGPT or Copilot or whatever, right? Typical conversation is fairly short. You say a sentence or two, especially if you're typing that something you'll type in, and then you get an answer which might be slightly longer, but how much longer, right? That's one. Another is, say, on the Copilot side, what we do is somebody wants to summarize a document or a presentation or even the whole Teams call, etc. That's you're starting with a somewhat larger thing and you're trying to get a short summary. And then there's the, say, O1 or whatever, where you are exploring a whole bunch of ideas before you actually spit something out. In this case, you might have started with a small question, but you're taking a long time to think about things and generating a whole bunch of tokens before you actually. So lots of different scenarios. And then the third axis, in fact, is the hardware itself. So if you take just one company, say NVIDIA,
Hmm.
they keep releasing a new GPU with some
Hmm.
cadence, right? 6
Yeah.
months a year, whatever.
Yeah.
Now you add that AMD to the mix, which is doing the same thing as well, with a slightly different cadence. And then our own third internal one, Maya, which is again similar things. And they each have their own different things that you have. Now you put all these together and you are in a place where you want to get the best performance extremely quickly, ideally the day anything new lands. So if you have a new hardware, you want the existing models to run on that super efficiently. If you get a new model, you want to on all the existing ones. And how do you do all of this at the same time, right?
Yeah.
So that's what makes it hard and interesting, right?
Yeah. So it's the inferencing is not like somebody has defined the architecture in whatever graph they do, PyTorch or something, and you just run it. Compile it to the hardware and start running it. There's a lot.
I wish.
Tell us more. What goes in there? What kind of optimizations? Like, we have obviously seen the orders of magnitude decrease in the inference pricing.
Yeah.
How's that being made possible?
Yeah. So I would say from the end user perspective, the improvements that we see are across, again, a few different axes. Some, talking about this core inference, the hardware, for example, are improvements in hardware itself.
Yeah.
Over time, we keep getting more performant hardware that, for the same power envelope, essentially gives us faster results or cheaper results or whatever. Right? So that's sort of number one.
Yeah.
Number two is software that works with this hardware that can take the same model, the same algorithm, and make it faster. And I'll give you a couple of examples that people in this space know, like attention change to fast attention or fast attention 2, which are algorithmic changes in terms of how fast you can run part of the model itself on a given piece of hardware. Right? No change, no other change. The same the same model, the same hardware. You're now running it a lot faster.
So the mathematical structure of the model is the same, but the code that evaluates those nodes is somehow faster and fast attention.
Exactly. So what often happens is, if you take a model and try to run it on a piece of hardware, even though the hardware might be capable of a lot of flops or a lot of memory, the software is not able to take advantage of all of that. So we're only utilizing some percentage of that through some point, right? And they're often bottlenecks when you start. And so the software improvements and some algorithm improvements in the software can literally help do that.
So it's like using wider registers for doing math, or
using
more complex
registers
instructions.
more efficiently, more what we call double buffering. So sometimes you're memory bound. How can you reduce the effects of that? How can you overlap more of that with computation, etc.? So lots of different tricks. Ideally, those tricks would work for everything as is, but turns out you often have to. Somebody actually has to go in and tune that, etc. Talking about compilers. In some cases, compilers can help speed up the effort, but often for new innovations, they don't come. The compilers are great at taking an idea and now being able to do that over and over again on new models and perhaps new hardware, but not so much newer innovations. That's still people often involved, right, in doing those.
So you're saying that AI is not going to replace software engineer anytime soon?
Yes, I think that's going to be a while. While we would love to see that, and we talk about a lot of startups, it's definitely making people more productive. I would say this space not so much, and I know engineers on my team have tried that and haven't seen that much of a win, especially for somebody who really knows their field even today in lots of parts of software. They can be still pretty effective, right? So those are two directions. There are a couple more, I would say, right? Some have been on the ML side, algorithmic improvement, for example, different types of attention. So attention is one of the pieces of the transformer models, right? GPT models that we have today. And people have used traditionally, are you going to attend to everything before, like a long context, which if you have, let's say, 10,000 words or whatever, that's going to be expensive. And now you go to 100,000 or a million, that's even more expensive. You're growing linearly, quadratically, not even linearly, right? To other variations that are going to grow much less. So we'll look at some parts. There are trade-offs, of course. So different models choose different ones. So that's one direction. But the other one that I would say has seen bigger ones is we've really learned how to once you have a model with some capabilities, we've learned well how to take those capabilities and deploy them with a much smaller model or a much more efficient model.
Yeah.
Smaller, different, whatever way, right? This is the teacher-student. We talk about distillation. There's lots of techniques there. Right?
Yeah.
And what that often helps is when we see a new model come out, say a GPT-4 came out a year and a half or so ago, it was, I think, $60 a million tokens or whatever. Today, it's, if I remember right, it's $10. I think we're talking about the outputs itself, right?
Yeah.
So a sixth of the cost in a year and a half. Over a slightly longer time frame, GPT-3 series, I would say, has gone from started around similar price, but now is, if you think of GPT-4 or Mini as that level, because it's still actually better quality, it's way better quality, but at like a very small fraction of the cost, right? And it's been a combination of these few axes that continues to grow.
And then I guess quantization is a fixed benefit, and things like early stopping, where you don't evaluate all the layers for certain tokens.
So there are lots of such ideas, right? Different areas have totally tried. Quantization, absolutely. I would say in general, going from, of course, 32-bit nobody talks about for the last few years. That used to be the case at some point. But even 16-bit, 8-bit.
Blackwell is 4-bit, right?
4-bit support, yes. And so all kinds of things that are definitely helping there for... Depends on the bottleneck. If it's a memory bandwidth, you want to make sure, can you compress weights and activations, and same for caches, etc. If it's compute, then how do you leverage the most compute, right? So all of those. And yes, algorithmically, things like the speculative decoding or like you're saying, early stopping, etc. Those are definitely ideas that people play with and look at.
So I think since it's the ideas that's driving part of the downward trend in inference pricing, are there more ideas in the pipeline that haven't seen the light of the day yet? Or does it feel like the low-hanging fruit has been picked off?
I think the way I like to think about it is looking backwards a little bit. Where were we 10 years ago, and how have we come? Has there been an arc that sort of continued? We didn't have these ideas, all of these ideas back then at least. Yes, we wanted to, like the first time we did FP16 or BF16 as we called it then, it was purely for communication, not even anything else, right? And it seemed to work, and it helped us because we were communication bound, and so we used it. This was 2012 or so. And moving from then on, 16-bit is a no-brainer. Almost everybody uses it, right? And people use 8-bit as well fairly commonly in lots of places, etc. If you had asked me then, are we clearly have the 8 working? Wasn't clear. And now if you talk about FP4 or something like that working for sure, we don't know exactly how to make it work, but the likelihood of making it work is fairly high. There are definitely directions just following some of those same directions that we expect to go towards, right? The hardware improvements, we're not going to see some magical things like, okay, now you can do a matrix multiply instead of a vector arithmetic. That is harder. But we are seeing improvements, etc. We're seeing power improvements, which actually in turn leads to a lot of these as well. Memory improvements. There are some more things in the same paths like we're talking about, and then there are some crazier ideas, right? You talk about everything moving to SRAM or whatever, which is like memory closer to the compute and a lot faster. There definitely, we can see today examples where it can be super fast in terms of that iteration. It's not cheap enough today. Right? Can it change? Yes. We can change the hardware, etc. So there are a lot of bets like that are happening in parallel, which even not all need to pan out, right? That's the good thing about some of these bets. Even if a couple pan out, that sets us up for another big jump, right?
Very cool, because that's the thing that we are all, these days I'm working on agents, and the whole bet of the agents is that it's not one inference, right? But you're gonna make hundreds of inferences before you solve a problem, and for that to happen, both the latency needs to go down and the cost of inference needs to go down, and even models like O1 where they inherently do a lot of inferencing before producing the answer. This trend is super important.
Absolutely. I agree that has to be a big place to go. If we think about the next set of improvements, I mean, will we have bigger models? Sure. Will they improve things? Yes. But almost everybody in the field also agrees that by itself is not going to give us full reasoning, etc. Right? We need something more.
Yeah.
And the directions like Owen are definitely helping us, and they seem to be doing a good job. And like for agents, like you're saying, being able to try out a lot of things is super important.
Yeah.
The directionally, I would say we are going in the right direction. Continue to be. It's not like we're hitting a wall yet.
So actually, Owen is the new exciting kid on the block. Let's talk a little bit about that. Can you tell us what is the idea behind Owen and how is it different?
I'll keep it high level, partly because not all the details have been shared, and partly just my own ignorance as well. And we should get your perspective as well, since you've spent a lot of time. Look, the basic idea there is when we think of something, especially if it's a harder problem, if it's a simple question, okay, who's the president of the United States? Sure, just you can recall from memory it's Joe Biden, and that's fine. But if
it's
you're
not as simple as you think.
If you remember, right? If you've read enough, that is fair. That is fair. But if it's a slightly more complex math kind of question where maybe you need to multiply two numbers, etc. By the way, that is one example, multiplication, that I've tried with the ChatGPT for a while, and it keeps getting better. It used to be like completely off. The last time I tried it like a month or so ago, it was off by just one digit. Amazing, but I can't trust it. So it's a weird one, right?
Yeah,
but if you could somehow, if I think about how I would do it, even if I could do the math in my mind quickly for a huge number, the thing is, to be sure, I want to be able to validate that. Right?
Yeah.
Or if you have 2-3 paths that I could take, I might want to explore both those paths and then maybe go deeper on two ideas, see where they go before picking one. And you can do that in current way of just generating the next token and so on, right? Which is mostly what we do. There are some smarter things we can do, but mostly what we do, right? And so the idea behind things like O1 is, okay, let's explore a few different paths and keep going until we have more confidence on what we're trying to do. So that's at a very high level, as simple as that. But I know with agents, and you've been looking at that. So what's your thought? What's your perspective?
So I heard the interview with Brown and his colleagues, and basically what they were saying was that if there is a class of problems where it's really easy to verify whether you have gotten the right answer or not, but it's hard to produce the right answer, then you can keep searching and you can keep trying different ideas, and that's what essentially O1 is doing. I think the interesting thing for me is that the idea of chain of thought or tree of thought was already there, and you could prompt for, let's think step by step and let's break it this way or that way, and then the model will produce better answer. It seems like they've used reinforcement learning and a lot of hard math and computer science examples to train something that can guide this exploration and kind of say that what is the right time to back off from a particular branch of reasoning, or like among 5 branches which one to go to, and that's the stuff where I guess the details have not been published, but I would love your opinion on that.
Look, specifically on this I can't say much. It's a closely guarded secret for good reason. But it's interesting, right? Just taking a very different example, and if you think about chess or Go, right, where we saw computers do extremely well at some point, there the problem was much more limited. But at the end of the day, what let it work well was a few things. You're still trying all these different paths. You have a way of scoring how well each of those paths seem to be, right? And you can use those scores, those evaluations, to guess and not go too far, etc. Right? That was, if you think about the difference between, say, AlphaGo or the AlphaZero, which could also play chess, etc. The difference between that and Deep Thought or Deep Blue, which basically ended up beating Kasparov for the first time, was at that time we were both to incorporate a whole bunch of chess-specific algorithms, and two, we had to go a lot deeper, a lot more computation, because we couldn't evaluate well enough. The evaluation has gotten a lot better in today's world. So if you can apply those same ideas to evaluating whatever you're thinking of, that's super interesting. And in the agent space, it gets like super important, right? If you are just asking for an answer and somebody's taking a decision on it like a human, that's a lot easier. You can be wrong.
Yeah.
But if you're asking, like with the agents, the expectations they're acting on your behalf,
Yeah.
making a decision and then acting.
Yeah.
And then it's much more important for the decision to be right.
Yeah, I think we're going to see a lot more agents interject in our workflows, and for more critical things, I guess there'll always be a human in the loop verifying. And one of the things that we are looking at is how do we make verification easy for the humans so that you're not just dump an answer in front of them and say, you go figure out what it is, but give them tools so that they can look at something and say, what's the evidence for that? And the tool brings that back. We're working with a pharmaceutical customer where the questions are like, my patient is anemic, and should the doses for chemotherapy be changed? You can't screw that up.
Yeah, absolutely. Yeah, I mean, for those cases, you definitely want a human in there that's collaborating in some sense, right?
Yeah. But I guess the thing that's interesting to me is how do we build tools that make it easier for the human to validate certain things with high confidence? And those are some of the things that we've been exploring, and it's been a lot of fun.
And one thing I liked about that space, or how we think that it's as much of a human interface piece as the tech itself. We've talked about computer-human interaction, etc., and we think of it as UIs.
Yeah.
No, it's not a UI in that sense, traditional sense, but super important to think about the product and the experience. At least as important as the tech. Right? In fact, that's where we might see the biggest exciting things happen. Right?
Yeah. I guess it's one of the most interesting times to try and predict the future. Because I guess as much as we try to keep reading the research papers and the Twitterverse of AI, nobody really knows what's going to happen in the next 1 year, in the next 5 years. So with that note, let's let's make some predictions. So where do you think we're going to be, let's say 2 years from now in this AI world, and maybe 5 years from now?
Interesting. You're putting me in a tough spot. Look, most of these predictions are wrong. 2 years, I would say.
You know a lot more than most people. But I'm sure you have an alpha.
By the way, if you read enough of, what's that book? Basically, if you read about how people make bets or people make predictions, most often individual expert predictions are wrong. But if you can take people who are systematic about making predictions, even if they're not experts, you take enough of those and you have a good way of putting them together, those end up being better. But that aside, let's still make, why not? I would say 2 years is almost, I think it's an easier one in that I don't expect any shattering changes in that time. It's
no AGI?
No AGI. I am not one of those who believes that AGI is right here. Yes, at some point it might happen. In fact, AGI, I don't know. I'm not even sure if AGI is the right terminology. Right? We have AI that's super good and it's very useful in lots of ways. There are lots of things that we can do to make it better, of course. And so a lot of things over the next couple of years are likely to be more incremental. They'll feel like bigger changes if we get a newer capability, like we're seeing with this reasoning. I think this is the first phase of reasoning. Just GPT-3.5 came out. People are like, oh wow, the technology had been improving for the last 5 years, right? And it suddenly started to make sense. And over on the reasoning side is still the early first example of that, right? And we've been talking, like you said, of chain of thought, tree of thought, etc. already. So this is already an evolution of that. I think just the basics in that will improve over the next couple of years, where perhaps the reasoning stuff becomes much more useful, say in the agents areas that you were talking about. So that feels like the most closest thing that we might get to and feels doable. The 5 years is, I would say, harder. For a lot of reasons. I think the change, are the models, etc., going to get better? I mean, sure. The AGI, again, will it be much better? It'll be better. I don't think in terms of will it be Like, will it take over the world? Like some people, I don't think so. Should we be mindful of how we treat it and be careful about this technology? Absolutely. It doesn't need to be a super intelligent thing for to be risky, because there are enough people in this world who will try to make things with it that are problematic. So those things are...
Personally, what would you love for it to be automated away from your life?
So the third, one thing I was going to talk about, and this is one that I've been wanting to see for a long time, is self-driving cars. They keep getting better, but they're not there yet. Even with whatever Elon Musk says, so it's this year, next year, and he's been saying this for the last at least 5 years, maybe longer. It is actually getting better. There are real companies starting to build. We're seeing, being in the Bay Area, I guess you see enough Waymos, particularly if you go to San Francisco, etc. Right? And the experience is good. And I don't think they have a business yet. It's still too expensive, but I would like to see that happen in 5 years. Maybe I should change my goal. 10 years ago or so, 2010, I thought, okay, we have a chance of... I made a bet that in 10 years we'll have self-driving cars on the road with somebody, and we did have, but they weren't really in a very limited fashion. Now, and my hope was that my son won't have to drive. He's driving. Maybe my daughter won't have to drive, and she still has some ways to go. But actually it changes my experience and the risk on the road. So I believe in that, right? Other things, look, there's the more mundane things in some sense. We talk about productivity, etc. And some people talk about, we're going to replace so many humans, etc. Perhaps in some places that will happen. But what I would like to really see a lot more of is making our more routine tasks being just taken care of. Right? If you had 5 people around you who were taking care of things without you having to worry and tell them and monitor them, etc., it wouldn't be bad. And particularly because so much of our stuff is now virtual, it's just online. If you have the right agents like you're trying to build, they can actually help make my life a lot better. Where I can just focus on actually being away and not on my phone half the time, and spend time with the family or friends or whatever. And so in some ways making our lives a bit less technical, you could say, or whatever, which is weird coming from a person who likes less tech.
But tech needs to be there, but not intrusive, is what you say.
How do you? I should, given that we're talking about this, you definitely have to answer it as well.
So a friend of mine was saying this in a very funny way, which I absolutely love, which was that we used to think that when AI is here, we'll have robots to do our dishes and house cleaning and laundry, and we would be the one writing poetry and jokes.
I see where you're going.
It's gone the other way around. AI is writing poetry and jokes, and we're still doing our dishes and laundry. But I guess robotics is the next wave. So hopefully these...
it still seems early for robotics. If you talk about the 5-year time frame, it feels like it's more doable. And of course, it's always easy to say, 5 years and everything. But it's still, the early part of robotics definitely seems like it's working. So hopefully in 5 years we can make it more real.
Very cool. This was an amazing technical discussion. I want to bring it a little bit to the personal domain before we close it. Let me ask you this. What are some of the best tools you have found in your life to deal with adversity?
So I think some of those can be very personal. It's important to, especially in the age we live in and the kind of lives we live, we want to do everything. There's always FOMO about something. And that's fine. Do as much as you can. It's important. What I've felt has helped me stay sane in many of these areas is building some simple things in the work life, whatever, your life overall, that are like, okay, I'm definitely going to keep this because this gives me happiness. Right? That just makes my day where I can go through anything else in the day, etc. And that, like, what that is has changed over time. Like these days, Friday afternoons, most Fridays I like to go play pickleball with some friends. And I try to keep that, however busy things might be, right?
Yeah.
There are a couple of friends that I try to meet regularly and for lunch or whatever. And I'll try to keep that super hard if possible. You know, not miss. And that really keeps the rest of the things okay, because yes, we will have tough times. There are ups and downs, whether it's work, home, family, whatever, right? Spending the time with the family, with each person in a different way, etc. But whatever that connects, right? It's some hobbies or whatever that you disconnect. In my case, I talked about pickleball, used to be swimming, something else, right? But something that just lets me disconnect. And that the people that really matter, being able to connect with them, being able to spend a little bit of time, that's super important. Actually, one more, just for staying fit. Right? For the longest time growing up, I was like, fine, I play, that's fit enough. And it was fine. Over time, as you grow, you realize that it's very easy to spend all your time doing work or something else. But fitness helps you mentally as well, not just physically. And just that's another thing that's really made a difference.
Yeah, I think I heard somebody say that contracting muscle releases certain chemicals in your body. That's the best antidepressant you can hope for.
Yeah. Do you have some tricks on your side?
I think off late I have really started leaning hard on things like meditation and exercise and staying in touch with friends. One of my favorite things these days, and it used to be in college and then I lost touch for a while, and these days, is that I collect jokes. So I don't write jokes, I don't come up with jokes, but I'll listen to certain YouTube channels, I'll read books, and I'll go through 50 jokes to find the 2 that I really like. And then whenever I have 5 minutes, I'll call a random friend and share that joke with them. Like, I don't forward jokes like other people do. I love the 2-minute of sort of experience together of actually telling the joke.
Yeah.
And it's an absolute blast.
Yeah. I can believe that. That one thing I feel like I didn't do enough for, and I still would love to do more, is just laugh more, right?
Yeah.
And it's hard to, there are only some people that you can really laugh wholehearted with, right? Close friends, and so it's important to do that, and makes a difference.
Yeah. The other question, let's say that there's only one book that you could give your children for wisdom when they grow up. Which book would that be?
No. One book is tough. I actually love reading, and I've been reading a lot of books lately. And maybe this one's a bit more. I read Nexus by Yuval Noah Harari recently. I wouldn't say that one is the best one. It's good though. If you read regularly, I would recommend that. But an earlier book from him, Sapiens, is definitely a really good one. It's one for. It gives a different perspective on how to think about things, about humans. And often the way I think about it, it's collections of different things. Honestly, you learn not just from one thing, but lots of them. But I really like that perspective, the perspective of storytelling, the perspective of weaving in the history. And over time, actually growing up as a kid in India, history could never have been a fun topic, right? I rarely know anybody who loved history. But over time, I've started enjoying it a lot more because there's so much to learn from there. Right? And we talk about history repeating itself. That's so true. There's so many things that you can map onto. If you knew, then you can really learn and not make the same mistakes again. And I felt like this did a great job with just that understanding some of that history as well.
Okay, one more. What's the kindest thing that somebody has done for you?
Ooh. Lots, but the kindest makes it harder.
It's not a competition, just pick one. One of the kindest things that somebody has done.
One of that really stands out. I would say, look, and I'm going to be a little general, not picking a specific example here. But I feel like, again, depending on who the person is, it's hard to give something that's dear to you in some sense. And for a lot of people, I feel, myself included, it's the time. It's precious.
Yeah.
Right? And with some folks around me, like some close friends, etc., who've given me that time when I really needed that.
Mm-hmm.
There are times when I've been through hard times and just needed somebody to talk to, and thankfully it's great to have my wife and a few friends that I can reach out to anytime and just have that. And that's just beautiful, right? It's hard to replace that, and it really makes a difference.
All right. And other than the usual things people say about family and health and being fortunate in terms of career,
Doing all of three.
What is the thing that you feel grateful for lately?
I guess a lot of things. Yeah, you say the right things. You covered. You removed the most important ones.
There has to be new bits of information in there.
Yeah. Look, I think in some ways, like you said, all of those pieces are there. What that's let me do or be, in some ways, be myself or be unlimited. There's nothing limiting what I can think of, or I can think of, say, changing the world in some way, right? Because those are there.
Yeah.
Otherwise, I couldn't. You talk about Maslow's hierarchy or whatever. You need to have the basics and stuff. Yeah. And just being near the top because I have all those is amazing. Yeah. And yes, I'm truly grateful to be there because that has allowed me to think about and make choices and do things, and continues to today. Yeah. Which I just wouldn't be able to otherwise.
And if there was one message that you could give to everyone in the world.
Wow. Yeah, really cool topic. Oh man. This will start to sound like, okay, I'm getting old enough, and it's like people, and this is, you learn from different things, etc. And there are things about, okay, what's important to you in life. It's important to be able to think about that, and usually for most part you hear that, yes, when you are near the end, you're thinking about the people near you, etc. Well, that's fine, right? If I think about, this is again, not everybody wants to hear this because they're not at the right time, right? And so one important thing I feel, and I was talking to somebody about this yesterday, so it's fresh, even knowledge or wisdom, knowledge is there, we get that all the time. But there's only certain times where we are ready to absorb it, right? To really get that wisdom in some sense, right? And it's okay if you're not ready for something, there will be a time. Or if not, it's not important, right? But and it reminds me of a quote from one of my profs way back in college, was, wisdom cannot be taught, it can only be learned. And I think that's a very apt thing. It's important, and it's important to be comfortable with that too.
Yeah. That's a great note to end this podcast. Thank you so much for giving the gift of your time and sharing that with us.
Thank you.
It's been such a pleasure to talk to you on this podcast. We otherwise keep talking.
I know. Thank you so much. Great. Always great to talk to you, of course, Amit, and thank you for having me here.
Thank you.